What if I told you that right now, at this very moment, something is racing through our solar system at 150,000 miles per hour, carrying what might be humanity's first evidence of alien technology? And what if I told you that in just 2 months, it's going to disappear forever, taking its secrets with it? This isn't science fiction. This isn't speculation. This is 3I Atlas, the third interstellar visitor ever detected, and according to Harvard's top astrophysicist, it might be running on nuclear power. Not solar power, not chemical reactions, nuclear energy, like a spacecraft, like a probe, like something that was built. Welcome to Space Prime. I'm your host, and today we're diving deep into the most controversial discovery in modern astronomy, a discovery that's forcing scientists to question everything they thought they knew about what's possible in our cosmic neighborhood. The impossible object. Let me paint you a picture of what we're dealing with here. Imagine you're an astronomer, scanning the night sky, when suddenly you spot something that shouldn't exist, an object that glows from the wrong direction, an object whose orbit looks suspiciously engineered. This is exactly what happened when 3I Atlas was first detected. From the very beginning, this thing has been breaking the rules. Most comets are predictable. They follow a simple script written by the laws of physics. As they approach the sun, solar radiation heats their surface, vaporizing ice and releasing dust. This creates that classic comet tail we all recognize, always pointing away from the sun like a cosmic windsock. But 3I Atlas didn't get that memo. Instead of a traditional tail streaming behind it, this object produces a faint, consistent glow in front of it. Think of it like the difference between a car's exhaust and its headlights. Normal comets have exhaust. This thing has headlights. When scientists first noticed this anomaly, they tried to explain it away. Maybe it's just reflected sunlight bouncing off a dust cloud, they thought. But then they ran the numbers, and that's when things got really strange. The dust cloud around 3I Atlas is what astronomers call optically thin. In simple terms, that means it's not dense enough to reflect much light. The particles are too scattered, too sparse, too far apart to produce the brightness that our telescopes are detecting. So they tried a different approach. If this is just reflected sunlight, they calculated, then the object itself would have to be enormous. We're talking at least 20 kilometers in diameter, nearly the size of Manhattan. But here's the problem. Size estimates from both the Hubble Space Telescope and the James Webb Space Telescope place 3I Atlas between just 4 and 11 kilometers across. Do you see the contradiction here? This object is too small to shine this brightly through reflection alone. It's like seeing a flashlight beam that's brighter than the flashlight should be able to produce. Something doesn't add up. The Harvard hypothesis. This is where Avi Loeb enters the story. Loeb is no fringe scientist peddling wild theories from his basement. He's the former chair of Harvard's astronomy department, director of the prestigious Galileo project, and one of the most published astrophysicists in the world. When he speaks, the scientific community listens, and what Loeb is saying about 3I Atlas is revolutionary. According to his analysis, if the light we're observing from this object is simply reflected sunlight, then it would need to be bigger than Manhattan Island to produce that level of brightness. But we know it's not that big. So where is the light coming from? Loeb believes we're not seeing reflected light at all. We're seeing emitted light, light being generated by the object itself. But here's where it gets really interesting. The glow we're observing isn't random or chaotic like you'd expect from natural processes. It's stable, it's controlled, it's consistent over time. And the amount of surface erosion recorded over months of observation? Less than a millimeter. That rules out the kind of violent outgassing we'd expect from solar heating. So if it's not sunlight and it's not dust, then what is powering this glow? Loeb's hypothesis is that 3I Atlas contains an internal energy source, not chemical energy, that would burn out quickly in the harsh environment of space. Not solar energy. The object is too far from any star for most of its journey. Nuclear energy. Think about it. Nuclear reactions are the most efficient, long-lasting source of energy we know of. We use radioisotope thermoelectric generators in our own deep space probes, precisely because they can operate for decades without any external power source. A chunk of plutonium the size of a basketball can power a spacecraft for 30 years or more. If 3I Atlas is indeed powered by nuclear reactions, it would explain everything. The consistent glow, the lack of traditional comet behavior, the precise orbital mechanics we're about to discuss. But it would also mean something else. It would mean this object was built because natural processes don't create nuclear reactors. Intelligence does. The engineered path. Now let's talk about something that should make your skin crawl. The trajectory of 3I Atlas. Space is chaos. Interstellar objects are born from cosmic violence, shattered in collisions, hurled by gravity, scattered by the restless churn of galaxies. When they enter our solar system, they typically do so like cosmic debris, with steep, erratic paths that show no regard for order or symmetry. But 3I Atlas is different. It doesn't crash into our solar system. It glides. Its path cuts through our cosmic neighborhood with eerie precision, traveling almost parallel to the orbital plane of the planets, only 5 degrees off the ecliptic. That's the same plane where Earth orbits, where Mars orbits, where Venus and Jupiter orbit. It's also the same corridor we use to launch our own space probes. But wait, there's more. 3I Atlas will pass near Venus, then Mars, then Jupiter, 3 of Earth's closest planetary neighbors, in a nearly perfect sequence. It's like a cosmic tour of our solar system's most interesting real estate. And here's the kicker. Just when its activity should peak, when it gets closest to the Sun and we should be able to observe it in maximum detail, it will be completely hidden from Earth's view. The Sun will sit directly between us and the object, creating a perfect cosmic blackout during the most critical observation period. It's as if the object chose our blind spot on purpose. Avi Loeb calls this trajectory suspicious. He compares it to how we designed the Voyager missions, carefully calculated flybys that use planetary gravity to maximize both data collection and momentum. The difference? We didn't build 3I Atlas. At least, we don't think we did. Some scientists dismiss these observations as coincidence. Orbital dynamics can be weird, they argue. Mathematical anomalies happen. But here's the question that keeps me up at night. How many coincidences add up to a pattern? A strange glow that defies explanation. A perfect trajectory through our solar system's most interesting regions. A cosmic blackout at the moment of maximum scientific opportunity. If this object is natural, then the universe just got a lot stranger than we thought. But if it's not natural, well, that opens up possibilities that most scientists aren't comfortable discussing in public. The deep space data. The deeper we look at 3I Atlas, the stranger it becomes. And we have some of the most advanced space telescopes in human history pointed at this thing, gathering data that's reshaping our understanding of what's possible. The Hubble Space Telescope, orbiting 340 miles above Earth, captured high-resolution images of the object's coma. That's the gas and dust cloud surrounding its nucleus. What Hubble saw was puzzling. The coma was faint, symmetrical, and completely wrong for a normal comet. There wasn't enough dust. There wasn't enough gas. There wasn't enough activity, period. Meanwhile, the James Webb Space Telescope, positioned at the L2 Lagrange point nearly 1 million miles from Earth, turned its infrared eyes toward 3I Atlas. Webb can see things that Hubble can't. Heat signatures, molecular compositions, the chemical fingerprints of cosmic objects. And what it found changed everything. The spectral analysis revealed water ice, silicates, and complex carbon molecules. On the surface, that sounds normal for a comet, but dig deeper and the anomalies start piling up. First, the material appears to be ancient, not just old, but untouched by radiation, frozen in pristine conditions since before our sun even existed. We're talking about matter that's over 7 billion years old, a fragment from the early galaxy, preserved in cosmic ice like a fly in amber. Second, despite being billions of years old, this material is warm, not hot enough to sublimate violently like we'd expect from a comet approaching the sun, but warm enough to glow, warm enough to radiate energy in the infrared spectrum. And here's the kicker. The nucleus is too small for the level of energy output we're observing. If solar radiation were doing all the work, heating this object from the outside, the nucleus would need to be twice its estimated size to produce the thermal signature Webb is detecting. But it's not twice the size. It's exactly the size our measurements say it is, which means the energy has to be coming from somewhere else, somewhere inside. In the vacuum of space, there's only one energy source efficient enough to maintain this kind of heat output over the timescales we're talking about: nuclear decay. Radioactive elements breaking down, releasing energy, generating warmth from within. It's the same principle behind the radioisotope thermoelectric generators that power our own deep space missions. Voyager 1 and Voyager 2 are still operational after more than 45 years, precisely because they carry nuclear batteries. Curiosity rover explored Mars for over a decade decade, powered by plutonium. New Horizons flew to Pluto and beyond using nuclear energy. The technology works. It's proven. It's the gold standard for long-duration space missions. And if 3I Atlas is indeed powered by nuclear reactions, it would explain every single anomaly we've observed. But it would also mean something that most scientists are reluctant to say out loud. This object was designed because natural processes don't build nuclear reactors. Intelligence does. The ticking clock. Here's where our story takes on a sense of urgency that should terrify anyone who values scientific discovery. Time is running out. On October 29, 2025, just 2 months from now, 3I Atlas will swing around the Sun, reaching perihelion, its closest approach to our star. This should be the moment of maximum activity, maximum heat, maximum opportunity for scientific observation. It should be our best chance to study this object up close and gather definitive data about its true nature, but we won't see any of it. Earth will be on the complete opposite side of the Sun, rendering us cosmically blind at the most critical moment. By the time 3I Atlas re-emerges from behind the Sun and comes back into our view, it will already be fading, accelerating, and heading back toward interstellar space. This may be humanity's only chance to study what could be our first confirmed example of alien technology, and we're going to miss it. Some missions might still be positioned to gather data. Juno is currently orbiting Jupiter. Psyche is en route to study metallic asteroids. But redirecting these spacecraft isn't simple. It takes fuel we don't have, planning time we don't have, and congressional approval we definitely don't have. Meanwhile, 3I Atlas is moving at over 150,000 miles per hour. That's fast enough to travel from New York to Los Angeles in about 100 seconds. Every day we wait is another day this object gets further away from us and closer to disappearing forever. We are quite literally watching the opportunity of a lifetime slip through our fingers. And here's what makes it even more frustrating. If Avi Loeb is right, if this object really is some kind of probe or spacecraft, then its current trajectory might be intentional. Think about it. A path that provides an excellent survey of our solar system's most interesting planets, followed by a clean escape during our period of maximum observational blindness. It's almost like someone planned it that way. The choice we face. So here we are, faced with a choice that could define humanity's future relationship with the cosmos. We can choose the safe path. We can call 3I Atlas a comet, file it away in our databases, and move on with our lives. We can ignore the anomalies, dismiss the nuclear hypothesis, and pretend that everything we've observed has a perfectly natural explanation. Or we can choose the harder path. We can ask the uncomfortable questions. We can acknowledge that what we're seeing might be evidence of intelligence operating on scales we've never imagined. Because here's the thing, if 3I Atlas really is powered by nuclear technology, if its trajectory really is engineered, if its behavior really is controlled rather than random, then we're not alone. And we never were. The implications are staggering. How long have they been watching us? How many other objects like this have passed through our solar system undetected? What are they looking for? What have they learned? These aren't questions science fiction writers ask. These are questions that Harvard astrophysicists are asking. These are questions that data from our most advanced telescopes is forcing us to confront. In the silence of space, there are no announcements, no formal introductions, no cosmic handshakes. There's only evidence, only data, only the strange and unexplained objects that force us to expand our understanding of what's possible. 3I Atlas might be that evidence. It might be our first glimpse of intelligence beyond Earth, or it might be the most unusual natural object we've ever encountered. Either way, it represents a turning point in human history, but we're running out of time to figure out which. So I ask you, the viewers of Space Prime, what do you think? Are we looking at humanity's first confirmed alien probe, or are we seeing natural phenomena that we simply don't understand yet? Leave your thoughts in the comments below. Subscribe if you want to stay updated on this developing story, and share this video with anyone who believes the universe still has secrets worth discovering, because one way or another, 3I Atlas is about to change everything we thought we knew about our place in the cosmos. The sky was never empty, and now, finally, we might be beginning to see what's really out there. Thanks for watching Space Prime. Until next time, keep looking up.